All right. So I'm going to still have the questions on the side if you haven't actually been able to go through all of them. But at this moment, I want to show you what are some answers to how, if you might have answered these questions, to kind of help you be able to figure out which category you fall under. All right. So the first one, what do you want to get out of this question application? You got to know that answer. That's got to be crystal clear. If you don't, focus on that first, then start actually doing the research on the actual infrastructure itself. Second question, what do you value most and what are you willing to trade off? Well, the cloud native startup would say things like they need to get to time to market as fast as possible. They want to spend less, and that means that they're willing to spend less time on infrastructure so they can spend more time focusing on the things that really matter to their customers and actually growing their business. And they know that they've got a tight budget and they really got to make sure that they're stretching their runway as much as possible. So they want to use things that are cost effective by default, so they don't have to think about or plan how to be cost effective. They know that they're only being able to pay for what it is. They're only paying for what it is that they're using. And so this trade-off is they're not able to actually then customize the compute layer as much as maybe the cloud optimized startup would, but that's okay because they know that what is most important to their business success. Now, the cloud optimized startup, this startup would really value customization on the compute layer. An example of what I mean by that is, let's say you're creating like a brand new database, and this is one that is never been seen before in the industry. And so what's essential to your business is customizing the compute layer so you have certain benchmarks, metrics that you're able to then put out in the market that's better than anything else. So that becomes a core part of your business. And that means that you're going to then have to do that customization of compute. So that could be one thing that is a must for you, and that's fine. Or maybe you might have made a key strategic decision that you want, there's certain open source, I guess things that projects that are out there that even though there are a lot of open source projects that have built in cloud native implementations, there might be an open source project that you really want to use and there isn't a cloud native solution for it. So you have to be able to implement that open source solution in a cloud optimized way. And then the trade-off then becomes that it's going to take you more time to get to market. And that's because you're going to spend more time on the actual infrastructure layer, it's going to take you more time and your team more time. But that's a trade-off that you're willing to make, having to then also manage that infrastructure. All right, the experience necessary to build this in the cloud. The startup that has no AWS experience, or maybe some AWS experience, they would benefit most from a cloud native approach. A lot of the cloud native services out there are much more approachable for people that have no experience or maybe just some experience. Now, that doesn't mean that if you have a lot of experience with AWS, you shouldn't build cloud native. In fact, you get the options of being able to look at both and choose what makes sense for you, your business, and your customers. But the cloud native approach is definitely one, if you don't have that experience in AWS, that is going to help you be more successful. The cloud optimized startup, they have experience in AWS. They're very experienced in it, and that's why they're able to then be successful even though they're still having to manage all this extra infrastructure. So now, does everyone else on my team have the skills necessary to build this in the cloud? So the cloud native startup, no, they may not. If they say no, they don't have this experience, then they're going to then want to go the cloud native option. The cloud optimized startup, if their team has experience in AWS, then they have the option of being able to go cloud optimized or cloud native. And then the last is Do they know how to architect for high availability? If they don't have AWS experience, they're not sure. That's where cloud native is going to help them be able to be more successful because those best practices are built in. Cloud optimize, if they know how to be able to build for scale and high availability, then they have the option of being able to go cloud optimize and do it themselves because they know how to do that, or they could go cloud native and just be able to move faster. So let's now go into what these things mean. So at the heart of being a cloud optimized startup is really being able to customize at the compute layer, which then boils down to really being able to utilize Amazon EC2, which are your virtual servers and the cloud. So let's look at what that looks like from an architecture perspective. You've got Route 53, which automatically routes queries from your domain to the nearest DNS server. These requests are then routed to Elastic load balancers, and then these load balancers then are going to help check the health of those instances, and they're then going to then distribute the traffic to either your EC2 instances, or maybe this could also be containers as well, where I put containers as an icon because it could be either one of those that it could. And then your application servers are then going to make requests to the actual database itself. There's a standby database that's in another availability zone that's doing continuous replication. So if one availability zone were to have maybe some servers were to go down in that availability zone, then your application could seamlessly route traffic into the standby database, promoting that one as the primary. And you could still be able to have happy customers, be able to serve them, without them noticing that there was anything down that happened. And on the right, the startup is also using S3 for being able to serve images at scale, and they're using it with a cloud, with a CDN, Amazon CloudFront, as this example here, to be able to speed up the delivery of serving those images, videos, and also even using it for their web assets like their CSS files, their JavaScript files. This is one area. I know there was a question someone asked earlier about, being able to speed up the delivery of their application. And this is one area that is definitely worth looking at. If you're, maybe you're already seeing that your application performance is a little bit slower, are you using a CDN to be able to speed up the delivery of your videos, your images? That's definitely an area that can really help speed up your application. So the cloud optimized startup. This is just a look of what is actually the price of admission. Yes, you do get the actual more customization at the compute layer, but it also means there's way more stuff that you have to manage before you even get to the app optimization, which is at the very top. So you have to do that and the high availability and the scaling and the backups. AWS is really just managing the operating system installation down to the actual servers themselves in the data centers themselves in those availability zones. But again, it's not as though you can't be successful in either scenario. It's not as though there's one that's better than the other, because you can be successful in both scenarios. It's a matter of choosing what's right for you in your business. So I want to give you an example. This startup, Kiswi, if they are a company that delivers ticketed digital experiences for live concerts and sporting events. They're a startup, and they, if any of you know BTS, the Korean K-pop sensation, they actually hosted the world's largest concert using a cloud optimized architecture, which was primarily on Amazon EC2 and Amazon CloudFront. So they were able to scale with this cloud optimized architecture to 756,000 viewers. So this broke the world record for the world's largest live streaming ticketed concert event. And it was absolutely seamless, successful. Everyone got to, love listening to BTS. So now let's go into the cloud native startup. And this is where I'm going to spend most of the time, because I really believe that like you're going to get the most benefits of being in the cloud if you choose cloud native options. I mean, this is a drastic difference here, just from the computing layer. If you go cloud native, I mean, you only have to manage the app optimization. AWS is going to manage everything else. I mean, I don't know, in my mind, I'm like, yeah, sign me up, I'm in. So here's an example of a cloud native startup. They're called Steady. They're a developer-focused platform for building automated EDI solutions that integrate with any business system. So they decided to be a serverless first approach architecture because they wanted zero-touch operations. And cloud native doesn't necessarily mean serverless, but serverless is certainly a fantastic approach to use if it makes sense. And I'm going to dive into when it makes sense to use serverless and when other alternatives can make sense for your business. So now let's go into the computing layer. There's a couple of different options for cloud native compute, and they all really boil down to containers or serverless. And I'm sure a question you might be wondering right now is, when do I use containers versus serverless? I'm so glad you asked. So you should use containers when maybe you've already started to build a monolithic application. At this point, you might realize that you want to break it up. Maybe it's becoming a lot slower to be able to actually spin up those resources and start it. And so you want to start breaking it up. Or another case could be maybe the application, the MVP that you need, it requires long running compute jobs. So this could be like either batch processing, maybe you're doing like genomics processing, for example, and machine learning is another popular example. And so you know that because it needs long running compute, containers is a great use case. Another common use case that I see is maybe you're like a B2B startup and your application needs to be deployed in different environments. So let's say you want to serve enterprise customers. Those enterprise customers, they might still have their own data centers. So you might need to containerize your application and deploy it in their data center, or deploy it in other cloud platforms wherever your customers run. Those are fantastic use cases for containers. So there's a couple different ways that you can run containers in AWS. There's Elastic Container Service, Amazon ECS, and I like to recommend this to customers that they know they have Docker experience, and they just want like a simple way of being able to orchestrate those containers. EKS, which is Amazon Elastic Kubernetes Service, I like to recommend that for customers who they're either already using Kubernetes and they now just want AWS to kind of help manage some of that infrastructure, or they already their research, they want to use Kubernetes. They've got a strong preference for it, and they just want help with AWS to be able to manage some of that infrastructure for them. Either way, I suggest using Fargate, which is going to remove the operational overhead of scaling, patching, securing, and managing those servers. So this means that the only thing you need to worry about is defining the CPU and RAM needs of your various tasks and services, and not having to worry if you have enough underlying compute to run it all. So this is serverless for your containers. It's pretty cool. Another newer option is AWS App Runner, and this is a fully managed service that makes it easy for developers to quickly deploy, containerize web applications and APIs at scale. And what was great about this is that it requires no prior infrastructure experience. It's like, here's my code, go put it on containers. So if you don't have containers experience, but you want to run containers, or maybe you don't have AWS experience, but you want to run containers, App Runner is a great choice for you. So now, when do you use serverless? So this is great where you want to spend as little time dealing with infrastructure, because serverless, you just give it your code and it runs for the duration of the time It spins up the right amount of compute. It auto scales your infrastructure. You're only paying for what it is that you use. High availability is built in. So this is definitely, I'm a huge fan of serverless. Serverless is also great if you're comfortable breaking up your code into small pieces. The way that serverless compute works is that you are thinking about these smaller bytes pieces of code that you can then be able to run and orchestrate in order to create these really complex applications. And then the last is maybe you want to make sure you're never pay for over provisioning your resources and that the actual resource utilization is optimized on your behalf. This is a stat that I absolutely love. And so if you're not convinced yet about like if I should go serverless, I hope this one does. And that's why I wanted to show it to you here. I mean, 409% ROI, 60% lower cost, and 33% higher developer productivity. So, wow. Now, serverless, this is actually more than just compute. It's actually a way of being able to develop applications. And the term that you're commonly going to see when you read more about serverless and start to really implement it is it's really event-driven compute. It's being able to run compute based on certain events and triggers that are happening in the environment. So let's look at an example from Lego's architecture. So Lego builds an event-driven design, and a lot of it they use with EventBridge. An EventBridge, this is a serverless event bus that makes it easier to build event-driven applications at scale using events generated from their applications. And the reason why they actually came to this application is because actually in 2017, they had a monolith, but they actually, during Black Friday sale, their entire systems crashed. And so they wanted a more scalable system and they started to decouple their application and they ended up coming up with this serverless application that you see here that's for being able to fulfill orders, processing, and shipping. All right, so again, I don't want you to leave here and not feel like you have things that you can take away and actually implement. So right now you're going to take a few minutes and I want you to write down, if you haven't started your building your MVP, was there anything that kind of stood out to you that you want to then go and implement? Or maybe you're not sure yet and you're like, I kind of like containers, but I don't know, maybe serverless. And this is a great time. Write those things down now. Or maybe I want to try App Runner. And those become the things that you're then, after today, you are then going to do more research on, or you're going to start implementing those. And maybe I know some of you have already started to build your MVP. So take this moment now to really check like, all right, is this the kind of the approach that I've started to build? Does this make sense? Or maybe for maybe some other features that I need to build, should I go serverless? Should I maybe use containers? Start to think about that right now and then write that down. All right. So the next common question is picking the right database. And oh man, this is a really important topic because oftentimes I see when customers do this right, they're able to really be able to scale and focus on more on the things that matter to their business and not on actually being able to try to fix dealing with fixing maybe some of their database, being slowed down by some of the decisions that they made by picking a database that doesn't necessarily fit their access patterns. So I'm going to get more into that. Now, with a cloud native database, what that means is, here's a difference. So on the left, cloud optimized. You got to do all the work. So, I mean, I hope you have a DBA if you're going to go with put a database on EC2, because you've got a lot of work ahead of you. But that also might mean that maybe that's a core part of your business, and that's okay. There's nothing, or isn't really a right or wrong answer here. But if you go with a cloud native database, there's a lot that AWS manages on your behalf. And so you really end up only having to focus on your schema design, query construction, and query optimization. And even with these three themselves, this still can take a lot of work and is a constant and never-ending improvement process for sure. But one common mistake that I see with startups, especially at the beginning stages, is, and I see them at the beginning and I see them later on 5-10 years later, is they pick a database that they're really comfortable with. For example, like, oh, I know Postgres, I know MySQL, so I'm gonna pick that, and that's what I'm gonna use. And they don't take the time to actually think about their access patterns, really think about if it's the right database for the actual application they're trying to build. And I see those startups later on where it actually causes some production pain, their team starts to slow down in productivity, and I don't want that to happen to you. Because in AWS, in the cloud, you want to think about picking the right tool for the right job. That's what's going to make you be able to be more faster, be able to really take advantage and let the tools in the cloud be able to help you move faster, help you get the insights that you need, and not be slowed down by any of these tools and not using them the right way. So there's really three things that you need to be aware of in order to pick the right database. First is identifying your access patterns. Then you want to, is it going to be a lot of read heavy, write heavy, reads and writes? What's the structure of your data? Is it JSON? Is it documents? Are there transactions? And then the time to actually execute. Because maybe even though a certain type of database, like a graph database, might be the better choice, it could very well be that the graph database, it might take you much longer than you anticipate to actually learn how to implement. So maybe you settle for a different kind of database, as an example, until you can start being able to really, utilize a graph database or for the features that you need. And this visualization I really like because it starts to be able to show you that based on certain factors, it's going to help you pick which kind of database you need. So if you need be able to get that data really quickly, you want to look for things towards the right. So you start to get, from warm is SQL, but then once you need a really fast request rate, you start looking at more NoSQL, maybe in memory if you need it as fast as possible. And same with latency. If you need the fastest latency, you might need a cache. Maybe if you need a database, maybe you need a NoSQL database. And I'm going to go into this more later on as well, but I want you to be able to see this. So there's a lot of different types of databases that are out there, being able to pick the right one. So knowing, is it, if you need schema, if you need ACID transactions, go with a relational database. Maybe you need low latency reads and writes, endless scale, high throughput, go with a key value database. Maybe you need to be able to store documents quickly and being able to access those. A document database would be a good fit for you. Maybe you need to be able to have a cache. And this is, I know there was another question I saw that was posted yesterday about about the performance being really slow to my application. And it's well, maybe have you tried using a cache? Maybe there might be some data that an example that comes to mind is I was working with a customer and they had an application for DJs of being able to request, being able to get recommendations for songs. And they noticed that there was a high latency of being able to go and actually get, a song that the DJ wanted to play. And I said, well, what about using a cache? There are probably certain songs that DJ is maybe more likely to be able to play. Why don't you cache those songs so then you have a much faster performance? And they were like, oh, I didn't think about that. So definitely look into a cache if it makes sense. Graph database. This is something that great use case. If maybe you're doing a social networking, you've got fraud detection, recommendation engine, these kinds of relationship type of queries that you want to be able to make, a graph database is going to perform really well for that. Time series. Maybe you're analyzing stock data, IoT data, Bitcoin trade data, anything that's where your time is the key variable that you're measuring and trying to run queries against. Time series is going to give you the fastest performance. And maybe a ledger database. This could be, you want to be able to have immutable and verifiable changes. All these changes are of the application. They're all in a immutable record. So maybe it's like I had a customer doing like supply chain logistics. So maybe every time in which an order has been reached a certain destination, having that in a ledger database. Maybe healthcare records. You want to have an immutable history of those records. And then wide column. And in this case, when I recommend this to customers, it's usually when I see customers that really love Cassandra, they're used to working with, and I hear a lot of like love-hate relationship with people who use Cassandra, where they love Cassandra, but they hate the management of it. And I think this is where I end up recommending them key spaces. So that might be you. All right, so I know this topic is like absolutely massive. But if you can just take some time now, and maybe there's some things that kind of stood out to you, like, oh, I need to look into this. Oh, that I have those kinds of access patterns. I want you to write those now, because this is really meant for, I want you to come away with this talk and actually have some things that you can start looking into and be able to implement in your MVP. Don't let this session just be information that doesn't actually help you take action. So I'm going to leave this up for a minute and then just write down right now. Is there a type of database that made sense to you? Maybe you already are using one database and you're like, you know what? I'm starting to see that maybe for this other feature that I'm building, it actually makes sense to use, maybe a key value database or a document database. Write that down now. All right. So yeah, I know. Usually I would take less time, but I know we're flying here. There's so much value that I want to be able to give you before you leave with me today. So here's an architecture of maybe what like a more cloud native type of web app architecture would look like. So it's a React app. Authentication happens with a cloud native service. In this case, is Amazon Cognito. All the API calls are then made to Amazon API Gateway. And this is just really the front door to being able to access the actual backend, and also throttles API requests as well. Lambda is then the actual where all the application logic is. This is the backend. And here it's DynamoDB is the database of choice. This is really common for like mobile app backends being able to use DynamoDB, but this could actually really be any other kind of cloud native database. This basic architecture in itself is what you can really essentially use. Just pick your access patterns and insert the database, and boom, you've got yourself your basic, like the fundamentals of a basic app. And if you are building a mobile app or even a web app, or you're new to AWS, and if you're new to AWS, it might feel a little overwhelming, like, oh my God, there's all these services and I don't know which one do I start using. I don't remember them. If there's one thing you remember, use AWS Amplify. And I would just write that down right now, AWS Amplify, because Amplify, it's a framework within AWS, and it's going to help you be able to implement these services behind the scenes without you necessarily having to know them. And they take into account AWS best practices, so cloud native best practices on your behalf. And you just have to think of things like, oh, I need storage, or oh, I need a database. Boom, let me go get it. And then click, CLI commands, boom, I've got myself a database. Woo! So definitely AWS Amplify is what you want to be able to use. Here's another common scenario, especially now that needing to be able to handle offline scenarios. This is something that's also like natively integrated within Amplify itself, is being able to handle these offline scenarios. But even if you don't, you could very well be able to do this without Amplify. You could be able to, as this service here is AWS App Sync, and this provides you managed GraphQL servers, and you're then able to resolve these queries, be able to for online and offline scenarios. So definitely App Sync is a service that you want to look up. You can write that down now. If you anticipate having a web mobile app and you need to be able to handle offline scenarios, that's a really common use case for it. All right, so I want to come back here because another common mistake that I start to see customers make, and it happens even sooner with startups, is, okay, so you pick one database and you start putting things in it, everything in it. All of a sudden, your data grows and grows and grows. And then there reaches a point, and I start to see it now occur with startups earlier and earlier in their actual growth phases. Even they're less than 10 years old, 5 years old, where they've reached a point where they're like, my database is starting to slow down. Queries are starting to get really slow. And I don't really know why. And that's because, one, they are not necessarily picking the right tool for the right job, but two is because they're starting to be able to store all of this data that's accumulating, and they're keeping cold data. But really, a database is really best if you're only keeping warm and hot data. And warm and hot data means like data that you need to be able to actually read and frequently, or you anticipate like, I'm probably going to need this data maybe in like a few months. But once you start, it gets to the point where it's like, I actually don't anticipate really needing this data, and it's kind of just sitting there and taking up space in your database. That's where you want to start looking into cold storage options. I'm looking at storage options. So that's what I want to go into next. And this is, again, happening more and more faster. Data grows. It's growing now over 10x every 5 years. And this is definitely happening faster and faster. And so even though you haven't even built anything yet, I still encourage you to start thinking about your data movement strategy of when it is that you're going to take data that's was warm and now move it into storage, because you don't need to access it as much. And so this pattern that you're going to see a lot if you start doing your research within AWS or just in the cloud in general, it's called a data lake. This is your centralized repository that allows you to store all of your structured and unstructured data at any scale. And this is where you're going to be able to scale out, because with your data lake in S3, there's really an infinite amount of data that you can be able to scale. You're going to be able to bring data from all different areas, from databases to maybe real-time clickstream, any place that you're starting to collect data. You can start to be able to store that in the data lake and then be able to make sense of it whenever the time is right for you. And this is especially crucial if your business where part of your MVP requires being able to create reports for your customers, maybe run analytics or do machine learning, then you're going to want to have to implement this right away. So now, as I'm kind of going through this phases of being able to do a data analytics strategy, I want you to start writing down where it is that you see that you're going to need to implement in the future or implement right away, depending on what your MVP actually requires. So the data sources, these could be from maybe a database. They could also be from maybe connected devices or other types of maybe like web sessions or cookies. So write down now, what is the actual data source that your data is right now from? It might just be a database, and that's totally fine. So from here, you're then going to write down where it is that you're going to be ingesting that data to. So are you ingesting it? If it's from a database, then you're going to, at some point, you're going to want to move that data using AWS Database Migration Service into S3, which I'll go into next. Maybe your use cases, like you're doing analytics for companies in rural locations. In that case, you're going to want to use Snowball. Examples of like maybe there's places like you're collecting data on a boat or in other parts of the world where there's just not very much internet connectivity. And so you're going to use a Snowball to actually have local compute in the area and then be able to bring that data in to AWS. Or maybe you need streaming use cases, like you're streaming data in from IoT devices, you're streaming clickstream data. This is where you're then going to use a service like Amazon Kinesis or Amazon Managed Stream Kafka to be able to actually stream that data into AWS. And even if, let's say maybe all these use cases applies to you, or just one of them, either way, all the data is going to go into Amazon S3 for storage. And then when you need to actually do your ETL, your orchestration, if you want a serverless ETL, AWS Glue is the place to go for that. I know I saw in the comments, the questions earlier, there was someone talking about managed Apache Airflow. And then this is where it kind of go in the stack, where your Amazon AWS managed Apache Airflow would read the data from pick up the data from S3, and you would then run your ETL from that data. So at this point, if you know that you're going to need ETL on that data, I would look at I would maybe write down Glue as a service you're going to do research on after this talk. Then, now, even if, let's say, you just have a database right now and you don't have an analytics strategy, like it's not important for your MVP, I would say even just having a strategy of being able to move the data from your database into S3 is going to save you money long-term, and at least it's going to set you up. So when later on you need to add features to run analytics, you're going to be just like so much more ahead of the game than other people. And so, yeah, definitely recommend it. And maybe if you're in that case, that's where like Amazon Athena could be really helpful for you. Amazon Athena is a serverless query service. And so you can run SQL queries right on the data in S3. And maybe in some cases, maybe your MVP, you are going to do reporting, but you don't necessarily want to like spin up a data warehouse like Amazon Redshift. You just know it's going to be kind of ad hoc. This is where also Amazon Athena could come into play. And then there's, of course, Amazon EMR if you're doing like, Hadoop, Hive, and you want to actually maybe have more control and customization of those clusters. Redshift, if you know that analytics is going to, and you're doing a lot of reporting, that's where Redshift can come into play. And maybe you need an Elasticsearch, like you want to be able to search logs or do Elasticsearch type of queries. Maybe you have a recommendation engine. Amazon OpenSearch is a tool that you can be able to utilize. So I'd write that down now of which of these tools, if any, make sense for you for your MVP. And then, of course, being able to consume that data. So I'm sure a lot of you here, maybe machine learning is the actual like MVP itself, like the model, being able to return those results, that is core to your business. Amazon SageMaker is definitely a service I would look into because it's fully managed and it helps you be able to just focus really on the machine learning and less on the infrastructure. And it's going to help you get models into production faster. Maybe you just need a front end and you just need an API, and that's where you could use API Gateway. Or maybe you just want to be able to quickly and cost effectively be able to show reports and visualizations and dashboards on your website. And that's where you would use QuickSight. So at this point, I know I kind of start to speed this up at the end because there's just like so much that I want to like value I just want to like give you in this time together. So if you've been writing things down, I just want to honor you right now and say congrats, because you have done a lot of work right now just to be able to get yourself forward to have an MVP that really works well for you, for your business, and it's going to help you grow and scale. And so you can spend more time on serving your customers, the things that matter to your business, and less on the infrastructure. Now, I want to leave you with one last thing, because I've been a startup solutions architect now at AWS for 4 years. And if there was just really kind of 10 things that I've seen successful startups or even just successful companies that I've worked with here that they do, even at the MVP stage, these are the top 10 things and that I want to leave you with that you can remember. So one is security from day one. Even though you are hungry to get that MVP as fast as possible into the market, successful startups don't ignore security. This is something that they continue to use and they continue to research, they implement. And I'm not saying that you're going to have the perfect security from day one. I mean, security is a constant, never-ending improvement process, but it's something that these successful startups are aware of, and they're constantly implementing things into their application to make them more secure. The second is infrastructure as code. This is something, I just had a conversation with a customer, and they now are less than 10 years old. They haven't done infrastructure as code, and now that they're thinking about, being able to scale their application, it's like you can just feel the weight of like, oh my God, now we have to start writing our infrastructure as code. Do it now. It's going to help you be able to plan a disaster recovery strategy, be able to move quickly if you need to be able to roll back mistakes. So start doing that early. All right. Successful startups, they know the problem they're trying to solve before they look into solutions. I have a customer that I've been working with. They just raised in the double-digit millions of dollars. They're now one of the biggest businesses in their category. And they came to me and they were like, all right, we want to look at API solutions. Can we talk about API solutions? Sure. What's the problem you're trying to solve? Crickets. I mean, really? Like you have this much money and you still can't tell me what the problem is you're trying to solve. So you've gotta be crystal clear on what it is the problem you're trying to solve. And then you can go and look into the infrastructure to actually solve that problem. Don't look for a solution and then try to discover what the problem is as you are at the same time. All right, number 4, successful startups, they ask for help and advice early. And they do it often. It could just be asking a solutions architect, hey, this is what I'm thinking. Can you help me? Hey, this is where it is that I want to go with my business. Can you help me here? And they're always willing to ask for help and advice. And so as a result, they're able to grow faster instead of just, assuming that they know it all, or they just do their research on their own, don't ask for help, and it actually ends up slowing them down. Number 5, successful startups, they're willing to experiment and adopt better solutions. I spoke to another startup and they have terabytes of data on a database. And this kind of goes back to the scenario I was telling you earlier about having, once your data starts growing and growing and growing, there comes a point where your queries start to slow down and maybe your costs start to go up. And you're like, I don't really understand why. Oh, I didn't optimize my queries years ago when I should have optimized them. What do I do? And so I gave them another solution to kind of experiment and adopt with. I was like, hey, if you use a data lake, you're going to save your costs and you're going to be able to, run the kind of queries that you want at scale. They were afraid to do that. Why? Because they were so stuck in their ways of, oh, but this is how I want, this is how I've been running this database before. Oh, but I'm so used to having one database to be able to do everything. And I don't want to have to change that. And I'm telling you, the successful startups, they are willing to see, is there a better way that I can actually be able to solve this problem? And they're willing to experiment and adapt to that. Number 6, they plan for the worst case scenario. And this is always a constant and never-ending improvement process. So I'm not saying that startups have every single possible worst case scenario always planned and they're always perfect. No, but this is something they know, like, okay, so we're going to implement this. We got to make sure we have high availability. Boom, check. And maybe later on it becomes, oh, we got to make sure we have a disaster recovery plan. Boom, check. And then they keep, this is a constant process of being able to start thinking ahead and planning ahead. They measure often. They measure success, and they are able to actually capture that data and know the metrics that they are looking for. They know maybe if there's SLAs, they know benchmarks of how fast they need reports to be in order to serve their customers. This is another example. I worked with a startup, and I'm trying to prepare them because they're in the e-commerce business and Black Friday is coming up. So that's a really big event for them. Now I'm trying to think. So I asked them, hey, last year, what did you scale up to? How many instances did you scale up to? Because you said that it was successful last year. They couldn't tell me. They had no idea. So I was like, all right. So, I mean, do you know how much traffic you had? They couldn't tell me how much traffic they had last year. So what my lesson is to you is you've got to be able to measure these important data points so that you can be able to constantly improve them over time. All right, number 8, I know I'm over time, but there's just so much I wanted to pack in here for you. So number 8, they use cloud native services as much as possible as it makes sense for their business. And that's because they recognize that the benefits of the cloud are being able to focus more on the things that matter to their business and less on things like infrastructure, which at the end of the day, your customers could really care less about what infrastructure you're using. Number 9, they provision the right amount of compute because they want to make sure that they're using money in the places that matters most, and paying for idle servers is a waste of money. So making sure that they're just using the right amount of compute and not paying more than they should. And then 10 is they learn best practices. Best practices, again, like everything on this list, is a constant and never-ending improvement process. So they learn what the best practices are, and they do their best to implement them. They ask for help when they aren't sure how to implement them, and they keep researching and learning what those best practices are so they can be able to keep growing, innovating, and making their architecture as resilient, as successful as possible as their business grows. Wow, I totally thought that I was able to do that in 60 minutes. So sorry, I kept you a little bit longer than I planned, but there's just so much I wanted to share with you to make sure that you actually have this plan. So I hope you took notes. I hope you now actually have, you should now have different services that you should be looking into in order to be able to start building your business that really makes sense for you. And I hope for those of you that came in that had an MVP, that you now know, okay, am I on the right track, or are there other things that I should be looking into? Because at the end of the day, there isn't really a wrong answer. The right answer is what makes sense for your business and to serve your customers. Thank you so much for spending this time with me today. I can't wait to see what all it is that you end up building.
Thank you. That was absolutely incredible. I mean, look at this chat. Everyone is saying thank you. You're a rock star. This is amazing. Great. Thank you so much. That was amazing. I'm going to go ahead and drop the link to the survey here for all of you CTO Fellowship Fellows. And then the link to the AMA next week I'll drop as well. All right. Thank you. Enjoy the rest of your day.
Thanks so much. Everyone. Good morning, good night, wherever you are in the world.
Go to sleep. All right. Bye, everyone.
All right. Bye, everyone.